Welcome to the Slop Temple. We pray this video helps.
You begin by making the GPU usable. Install the latest drivers and matching CUDA/cuDNN, then reboot if needed. Once done, install a GPU-aware framework like PyTorch or TensorFlow so you can target the device directly. Make sure the framework sees the card by running NVIDIA SMI and a small device list command. This verifies both driver and framework compatibility. If the card is visible, move code execution onto the GPU device rather than CPU to start leveraging parallel compute. You now focus on the heavy lifting. Avoid back-and-forth transfers by moving whole batches to GPU memory and operating there. Increase batch size within memory limits and enable mixed precision to speed matrix math. This reduces bandwidth and increases throughput. Use fused kernel ops or vendor libraries, cuBLAS, cuDNN, to cut kernel launch overhead. Profile the run with NVIDIA tools to find I/O or kernel bottlenecks. Then adjust prefetching, pinned memory, and asynchronous streams to keep the GPU fed. You finish by deploying with active monitoring. Watch utilization, memory usage, temperature, and power to ensure the GPU is saturated. If a single GPU is insufficient, scale with data or model parallelism and coordinate gradients across devices. When performance stalls, first check for excessive host-to-device transfers, small batches, or memory fragmentation. Then inspect kernel occupancy and memory access patterns. One key troubleshooting tip: if utilization is low, pin data, increase batch size, and profile to find the exact choke point to fix.
Thanks for watching. Consider subscribing if we helped you.